Dear student, this video is recorded to clarify the doubt in the assignment problem number 4. Let us look at the problem. Consider the piston cylinder assembly containing a pure gas zone below. The initial volume of the gas is 0.5 meter cube and the initial pressure is 1 bar. And the cross-section area of the piston is 0.1 meter square. Initially, the spring exerts no force on the very thin piston. Question number A. The block of mass m, that is equal to 2040 kg, is then placed on the piston. The final volume is 0.03 meter cube and the final pressure is 2 multiplied by 10 power 5 Pascal. You may assume that the force exerted by the spring on the piston varies linearly with the x, that the spring is very tight so that the volume of the gas is never less than the final volume. Precisely, draw the process on PV diagram. The question number 1 is draw the entire process on the PV diagram, labeling it as a process A. Drawing the area that represents the work of this process. What is the value of work? Given, find the value of the spring constant first. Okay. Now let us understand the problem here. Now let us understand the problem and let us convert them in the PV diagram. Initially, the pressure, only pressure acting on the piston, the thin piston, is the atmospheric pressure. Initially, there is no pressure from the spring also. Okay, that is the state I marked it here. How did I mark that? Point 1. The problem what they given is the volume 0.5 meter cube to pinpoint where is the position of state 1 in the two-dimensional graph. We need 2 points. Okay. So here they are given state 1, V1 they given 0.05 meter cube, comma, another thing I first know is pressure. They given the problem is the 1 bar pressure. So I know the 1 bar. So I mark a point at the point 1 since 2 point is given to me. Next, okay, let me look at the part A. A block of mass m 2040 kg is then placed on the piston. The final volume is 0.03 meter cube. Now the state 2. The given it is a volume is 0.3 meter cube, comma, the pressure they given 2 multiplied by 10 power 5 Pascal. So that can be expressed as 2 bar. Now I positioned the point 2 also. But the issue here is work done is not a state function, it is a path function. It depends on what path it undergone. So if you know the state 2 and state 1, I will not able to find what is the work done. So I need to consider what path it undergone. Then only I can plot this graph. I have given the solution itself, but I will tell you how this the plot can be plotted. Now just look at here. Initially the piston receives no force from the weight as well as the spring. So only force which exerts on the piston is atmospheric pressure. That's what given the problem. So from here to here, the height will be the P atmospheric pressure. That's what I mentioned here. Okay. Now the moment I'm going to place the weight, first the pressure on the piston will increase, and the moment I'm going to place the weight, even the spring will not act on that. Okay. The moment I'm going to place the weight, there will be there is a decrease in the volume of the piston, but there is a rise in the pressure. So the force on the piston should move rapidly in this direction. I want to know what is this distance could be first. Then only I can come up to this point. What is that pressure? Due to the weight, it is nothing but mg divided by A. It is the mass into acceleration is the force due to the weight placed on the piston divided by area, which will give the pressure. What is the pressure? P weight equal to 240 multiplied by 9.81 divided by 0.1. We will get approximately around 2 multiplied by 10 power 5 Pascal, which is nothing but 2 bar. That's why if you look at the figure which I given here, the piston moves from here to here. The difference is 1, 2, 3. It is nothing but 2 bar. Now the piston, the moment I am going to place the weight, the piston moves from here to here. So I found the path when weight is placed, but it's not as the only pressure on the piston by weight. Also, the moment I am going to place the weight on the piston moves down, but due to the spring force, the spring try to pull back the piston to its original position, but will not reach the original position. There will be some strain after placing the weight on the piston. So the piston again will try to move up. So now there are three forces acting on the piston. One is the pressure due to the system pressure, or let me call it as gas, that is equal to, then only I can have the equilibrium stage. So P atmospheric pressure plus pressure due to the weight and pressure due to the spring. But actually I know that what is the direction of each pressure. The spring will try to pull the piston towards the upward direction. That's what I given, the force due to the spring. The pressure exerts the force on the piston, that also in the upward direction. The mass will pull towards the ground, so gravity force towards the down. Also the atmospheric pressure try to push the piston towards the down. So these are the four forces involved here. At equilibrium, the P gas will be equal to the P atmospheric pressure plus P weight plus P spring. Okay. Now I want to find one of the hint in the problem is first find the value of K, this K value. For that, I know the final pressure, that is at the equilibrium condition, that is nothing but 2 multiplied by 10 power 5 equal to 1 multiplied by 10 power 5 plus P weight, that is 2040 multiplied by 10 power 9.81 divided by 0.1. Okay, and plus the force due to the spring. So F dx. Now I want to convert in terms of volume, because I know the change in volume, that is dV, or I can call them as a del V, since it is a definite change. Okay, del V, that is V2 minus V1 equal to 0.03 minus 0.05, V around 0.02 meter cube. Okay, to convert into dV, prior to that I need to convert the force into the pressure dividing by A and divide by A. So I'll be having here 1 multiplied by 10 power 5 plus this will be around 2 multiplied by 10 power 5 and plus, here it should be multiplied by A. Okay, multiplied by A and divide by A. Therefore I can convert dx into dV. So F dV divided by A square, this dV can be written as del V. So we know the value of this value, del V is a minus, it is a K, it is also K, not F. Okay, and minus 0.02. and the only unknown is the K. By substituting all the values, I can find K, will get K approximately 5.01 10 power 4 Newton per meter. Now I just determine what is the K value. Now I will calculate what is the work done during this process A. Yeah. Now let me come back here. What is the work done? Which I discussed in the class, that is nothing but W equal to minus PE dV. For us, there are three external pressure, that is integration of, first thing is, let me consider atmospheric pressure, P atmospheric pressure plus pressure due to the weight mg divided by A, and plus pressure due to the spring, that is F x divided by A into dV. Okay, then what I will be doing here is, since P atmospheric pressure and mg divided by A is not a function of V, these can be considered as a constant, and I want to convert this into, in terms of volume, multiplied by A, therefore divided by A. So what I will get is W equal to that is, I will integrate separately P atmospheric pressure plus mg divided by A into dV separately, and this term, okay, this term will be F into V A square into dV, and initial state is, what I know is, as per the problem, it is 0.05 and it is a 0.03, here also 0.05, 0.03. If you substitute all the value, let me do it one by one for you. Here I can take 1 multiplied by 10 power 5 into, if you know the value mg divided by 2 multiplied by 10 power 5 multiplied by, we integrate dV, we get V2 minus V1, that is nothing but, I will write V2 minus V1 plus 1 divided by A square. We integrate, sorry, it is a K again, I made a mistake. K value, you know that it is 5.01 into 10 power 4, and here V2 square divided by 2 minus V1 square divided by, sorry, not 2, yeah, 2, sorry, yeah, 2. And if you substitute value of V2 and V1, you will get the work done will be W equal to 5 multiplied by 10 power 3 joule. Okay, now I want to check this area will be, if you find the area under this line. Okay, now I want to know how this line is drawn, because it is simple understanding. I know that the moment I place the weight and the piston, the pressure moves from here to here, that is a 3 bar, and in the problem which they given, the final state is 2 bar. So only thing is I need to connect these 2 points. If you find the area under this box also, we get around 5 multiplied by 10 power 3 joules. Okay, let's look at here. And this area will be 2 into 0.03 minus 0.05, get same values. Okay, and 1 multiplied by 0.03 minus 0.5. Only thing is I am multiplied by 10 power 5. So I am converting bar into Pascal. Okay, and plus this of the value. Nothing but the area of the triangle will be of AB. That is 1 by 2. The base is again 0.03 minus 0.05 base. Whatever height is, this height is 2 to 3, 1. If you check the value, you will get let me keep the value as 2 itself. 2 plus 1 plus 1 it is 1 divided by 2. Okay, and 0.02 minus. Okay, and this will be 3 and 5 multiplied by and let us check graphically also. That is up to this the area of 2 rectangle here. So this area will be the area of rectangle. It is nothing but height is A into B. So nothing but 1, 2. So 2 multiplied by the width 0.02. It is a width. Okay, plus this right angle triangle of the base is 0.02 plus height is from here to here is a 1. So here it will be Let me multiply by 10 power 5. Here also 10 power 5. I want to keep in the Pascal so that I have work done in terms of joule. So here approximately it become 2 multiplied by 10 power 3, therefore into 2 plus 1 multiplied by 10 power 3. I am dividing 0.02 divided by 2, so I will get approximately, not approximately, 5 multiplied by 10 power 3 joules, same as what I have here. And if you want to know why it is the inclined line, and we can do other check also, that is, I will do that also here. So now I want to have the this plot is nothing but the plot between the P and V. So the moment the pressure reaches from here, the spring pulls down the pressure by expanding. Okay. So what is the pressure due to the spring? In the problem they given, yeah, spring equal to K into S, and I want to know the pressure of spring Kx divided by A divided by A will get F, sorry, K dV divided by K square, sorry, A square. So P is equal to K A square into dV. You integrate this or del V, sorry, here it is, it's not right, dV should be sorry, I made a mistake here, that is not divided by A, Kx divided by A can be written as K into A into X divided by A square, therefore K V divided by A square. So here P should be equal to K divided by A square into V. That is, P is proportional to V. That means it is a equation of straight line. It means volume, the pressure changes linearly with the volume. That's what I have a line, yes, inclined line. This is the way I need to find the work done graphically also. This is the area under the PV diagram. This is from state 1 to state 2. Now let us read the problem number 2. Sorry, problem part B. Consider instead of process in which a block of mass 1020 kg is placed on the piston in the original initial state, and after the gas inside has been compressed, another block of mass 1020 kg is placed on the piston. Draw the process on the same PV diagram. Labeling it process B. Draw the area that represents the work for this process. What is the value of the work? Here the problem is simply they divided the mass into two parts, 1020 and 1020. And we know that if I am going to divide the driving force into infinitesimally small, I will approach the reversible process. Definitely, by looking at this problem, the work done by the system in part B will be higher than the work done in the part A. since I'm approaching the reversible process. Let us solve how the same problem can be done. And I just given the result. I will show you how did we get this point. As I discussed earlier, the point 1, that is state number 1. This is state number 1. It is located here where the volume, the initial volume given as 0.05 and the pressure is 1 bar. Okay, now the weight is divided into 2. So first it will move from here to here. This position will be calculated by us. We have done it here. The weight number 1, P weight 1, pressure into the weight 1. The moment I am going to place first weight, the pressure suddenly increases. That is nothing but 1020 multiplied by G 9.81 divided by 0.1, we get approximately 1 bar. It will be 1 point something 0 1 into 10 power 5, that is nothing but 1 bar. So from it moves from here to here. So I just locating here. The moment the weight is placed, it rises, the pressure rises, then the piston will be compressed. Now that is an intermediate state. We know it's an intermediate state. As per the problem, there is no intermediate state is given to us. Now let us find what is this position. But I marked it here somewhere between this 2.5 something here pressure, and here will be the volume will be around 0. At 0. Near to the 4. Okay. Now I want to find the pressure, the intermediate pressure. That for that, what I'm going to assume is the process undergo changes where it follows certain law, that is PV power N equal to constant. You can even assume it is a isothermal process. Let me assume the pressure and it is a PV power N equal to constant. And I want to find the N so that I can find the intermediate pressure. For that, I will be using my initial and the final state which is given in the problem. So P1 N, P2 V2 N. From this I can calculate P1 divided by P2 divided by V2 divided by V1 power N, and if you substitute P1 equal to P1 is 1 bar and P2 is 2 bar and V2 is, which we know that 0.03 divided by 0.05 power 1 by N, you will approximately get the value of N 1.35. And now I know what is the N value. Now I can use this N value as a constant. I can determine my intermediate state. So now I'll be using that. Before that, I must know the pressure as well. So P pressure at intermediate state, Pi equal to pressure into the that should be P intermediate pressure system, that is equal to pressure due to the atmospheric pressure plus weight 1 plus pressure due to the spring, and we know that 1 multiplied by 10 power 5, this already determined 1 multiplied by 10 power 5, and P spring value we know that already done that. That is a 5.01 multiplied by 10 power 4 multiplied by dV, sorry, del V, V divided by A squared. And this will be approximately A, we know the 0.1. I'll be writing this term as, so that I can use it in future, 5.01 divided by 10 power 6. Okay, I'll be writing here. So I'll be adding this 2 multiplied by 10 power 5 plus 5 multiplied by 10 power 6, and I must know V intermediate minus V1, so that is equal to Vi. That's what I want to calculate. Now two unknowns are there, V intermediate as well as the Vi. Yeah, I'll be clearing out here. Yeah, this is nothing but sorry, I will take the previous step here. Yeah, I know the n value. So I want to, this is a P intermediate. Now from the relationship which I had, Pi Vi power n equal to P1 V1 power n, and if you want to find Pi equal to P1 multiplied by V1 divided by Vi power n. If you substitute here, so P1 multiplied by V1, that is 0.05 multiplied by Vi, and this P1 also can be replaced. That is the value of 1 multiplied by 10 power 5 equal to 2 multiplied by 10 power 5 plus 5 multiplied by 10 power 6 Vi minus V1, that is 0.05, and only unknown is Vi. By substituting all the value, by rearranging this equation, I will get Vi approximately 0.386, I think so. Yeah, 0.0385 meter cube. And using this, I can find the pressure value of intermediate again. It will be around near to the value. I'm not doing that. You can substitute again back if you want. I'll be even showing here. Pi equal to 1 multiplied by 10 power 5 multiplied by 0.05 divided by V intermediate pressure, that is 0.0385, power n is 1.35. You get approximately near to the 1.4 bar. P intermediate will be 1.4 bar, 4.8 something, 4.3 bar. Okay, so now I determine what is the position here. Now I can mark this point here also, this point. So I need to what I've done is I just applying two equations. I assume first PV power n equal to constant. Then from the state 1 and state 2, I determine what is the n value. Once I know the n value, I can determine what is the pressure of intermediate state, and I arrive this equation. Still I have some complexity, both Vi and Pa is unknown to me. Now I am just using the pressure balance equation, that is Pa equal to P atmosphere plus P weight plus P spring, and substituting all the value again. I'm having this entire equation in terms of VI, in terms of VI here, and I'm determining VI equal to 0.0385. Okay, once I done my these two cases, again I know that again I'm going to place another weight that also the same of 1020. The piston move from here to with a distance of 1 bar. You can check here. It moves from here to here. The difference will be 1 bar. So I hope I no need to do that. You can understand, because the moment I'm going to place the 1020 kg weight, the pressure raise will be 1 kg. That's what I have also indicated here, mg divided by A. Then only thing is simplest thing, I need to connect this state and the state to this area under the curve will be my work done. Let us do it in the manually also, and we can compare the value of both graphically as well as the manual value. Let me clear this one first. And now we need to calculate work done here. That is nothing but W equal to V1 to V intermediate, okay, and minus PE dV plus V intermediate to V2 minus PE. Let me put P external pressure. Two different external pressure we are having, PE and dV. And I will write the first one. Integration of V1 to V2. First, it is the moment the first weight is placed, it is combination of atmospheric pressure into one single weight. So 1 multiplied by 10 power 5 plus 1 multiplied by 10 power 5 into dV. I am splitting for the spring force also separately. So V1 to V intermediate. This is a V intermediate. Okay, here it should be we already converted into 5 into 10 power 6 because spring is K. I already written 5.04 into X. Okay, multiplied by A divided by A, and the force is divided by A. So divided by A. Okay. A is 0.1, so A square 10 power minus 2 will be having, you will get 5 into 10 power 6. Therefore, I will be getting here V. So if we X into A, so V, and this will be my dV plus V intermediate to V2. Here, just look at here, atmospheric pressure is same, 1 multiplied by 10 power 5 plus here the weight doubles, okay. So 2 multiplied by 10 power 5 into dV plus integrate V1 intermediate, to V2, 5 spring force is same, 10 power 6 V into dV. So if you integrate this, V square divided by 2, I have already done in the part A, and if you substitute all the value, integrate, you get V value around, work done will be 3.8 10 power 3 joule will be 3.8 kilojoules. Now let us solve the part C. Describe the process in which it will take the least amount of work to compress the piston. Draw the process on the same PV diagram. Labeling it process C. For this process, what is the value of the work? So here we know that least the previous case just made a small mistake. We'll be correcting that. W value what I obtained was is not a minus 5 multiplied by 10 to 6. It's a 5 multiplied by 10 power 3 joule for the process A. WB is equal to 3.86 something, 86 approximately kilojoules. Okay, and this also 5 kilojoules. And you can compare here, since I am dividing my driving force into small piece, the work done on the system decreases 3.86 kilojoule. And as per the problem, what is the least amount of work that can be extracted from the system, or not extracted, that can be done on the system to compress the system. So as we observed, as I am making the block into small pieces, the work done to compress the system, this decreases. If I am going to divide the system entirely into very small pieces, the work required will be very least. So I am approaching the reversible process where the driving force is infinitesimally small. For that, WC, the work done, is equal to minus PE dV. For the reversible process, PE can be replaced by the system pressure, P dV minus. Previously, I was giving here is a minus and minus. It's not a minus, it's a plus. Okay, right. Plus will indicate that the work done on the system. So V1 is 0.05, V2 is 0.03. And in the part B, what we done is P power n equal to constant and n equal to 1.36. Sorry, n equal to 1.35. So what I can do is I can replace this P in terms of each. Therefore, I can integrate. For that, I will be using the initial state P1 V1 1.35 equal to P at any position, at any volume V 1.3. Therefore, I want to find P equal to P1 V1 1.35 divided by V 1.35. And if you want to substitute back here, minus equal to minus P1 V1 power 1.35 integrate 1 dV divided by V power 1.35. Integrate V1 to V2, we get approximately the relation of this will be minus P1 V1 state V minus 1.35 minus 1 plus 1 divided by minus 1.35 plus 1, and substituting lower and upper limit, we get approximately 2800 joule, and that is nothing but 2.8 kilojoule. And we can compare the work done in all three processes. Work done in the reversible process is least. As I discussed earlier, we are going to divide the driving force into small pieces. The work done is gradually decreases. At infinitesimally small driving force, the work done is least to be done on the system to compress.